Welcome to Lesson 07, the one where we finally retire cron tab. Cron shipped in 1980. 5 fields, 1 text file, no structured logs, no supervision, no resource limits, no recovery from missed runs. Every shop has at least one 3 a.m. cron mystery in its history. System timers fix all of it by splitting the job into 2 unit files, a dot timer that schedules and a dot service that works, and inheriting every superpower the rest of Systemed already gives you. So let's establish the core pattern right away. Every scheduled job in Systemed is 2 files sharing one name. Here, backup.timer carries the schedule, OnCalendar daily, persistent true so missed runs catch up, and a unit pointer that's actually optional when the names match. Backup.service carries the work, a one-shot type and the exec start pointing at your script. And the rule that trips up everyone the first time: you enable the dot timer, never the dot service. System starts the service itself when it's due. Now look at the same job, a 2:30 a.m. log rotation, written both ways. On the left, 1 cron tab line. Elegant, sure. But if the box was off at 2:30, that run is gone forever. Logs scatter to sizelog or root's mailbox, and every server in your fleet hammers at exactly the same second. On the right, the timer plus service pair gains 8 things cron structurally cannot do: persistent catches, missed runs, randomized delay jitters the fleet, C group limits cap CPU and memory, journal CTL gives you real logs, and the whole thing is supervised. Same outcome, production grade versus 1980. Now, the syntax itself. OnCalendar reads like English compared to those 5 cryptic cron fields. You get shorthand keywords: hourly, daily, weekly, monthly. For the common cases, full-time stamps like **** space 023000 when you want to be explicit. And weekday ranges like Monfry 0900 that cron can only fake with a 1-5 in the day of week slot. And notice the last row, a one-shot at a specific future moment. Cron simply has no equivalent. These 10 patterns will cover 95% of what you ever schedule. Now, 2 flags that genuinely change the operational character of your timers. Persistent true tells Systemed to record the last runtime on disk. So if a scheduled run was missed while the box was down, it fires once on boot. That's your laptop backup. Your VM that sleeps overnight, classic cron recovery semantics. Randomized delay does the opposite job. It scatters fire times across a window so 1,000 servers don't all hammer the same upstream at exactly 2:30. The production pattern is both together. Persistent catches misses, randomized delay spreads the load. Make it muscle memory. Let's put it all together with 3 real cron tab lines you've probably seen on every server you've touched. Daily log rotate at 2:30 becomes an OnCalendar with persistent true. Hourly metric scrape gains a 2-minute randomized delay and runs as the monitor user via userspace in the service unit. Weekly Postgres backup gets both flags plus a 20-minute jitter window. The checklist is mechanical. Translate the schedule, pull the user into service, add persistent, add randomized delay. 5 minutes per line, and every one of those minutes pays you back the first time a job survives a reboot cleanly. Once that timer's running, you need 5 commands in your fingers. Systemctl list timers gives you the fleet view. Next fire, last fire, unit, service, all in one glance. Status on the timer tells you when it triggers next. Status on the service tells you whether the last run actually succeeded. Journal CTL-U pulls the history, and a plain systemctl start runs the service on demand, bypassing the schedule entirely. Run list timers daily. Run status before you ever touch a schedule. That's the discipline. With the discipline in place, step back and ask why this matters structurally. 3 principles separate engineers who know cron from engineers who design scheduled work. First, scheduled jobs are services. Same journal CTL, same restarts, same C groups. 1 mental model, not 2. Second, persistent true catches missed runs after sleep or reboot, which cron silently swallows. Third, Randomized delay jitters your fleet so 5,000 boxes don't hammer the same mirror at 2:30 a.m. One pattern, no missed runs, no self-inflicted DDoS. Now the cheat sheet, one page, the entire vocabulary. Top half is the 4 commands you'll type daily. List timers to audit, status to see next and last fire, start to skip the schedule, and enable, now for first deploy. Bottom half is the directives that actually shape behavior. OnCalendar for the schedule, persistent to catch missed runs, randomized, delay for fleet jitter, on-boot-sec and on-unit active-sec for boot relative and rate-limited triggers, and accuracy-sec when you need precision tighter than a minute. Print it, pin it. After a month, you won't need it. Reading is one thing. Muscle memory is another. So 3 drills, all hands-on. First, author a hello timer from scratch, a timer firing every 2 minutes, a service that echoes, and 6 minutes of journal CTL to feel the pair click together. Second, migrate a real cron line off your own box end to end, and check lib system first, because your distro has probably already done it for you. Third, run list timers, all and audit everything scheduled on the machine. Pick 3 you don't recognize, read their units, check their last runs. That last drill is the habit you want on every new server you ever touch. Before you ship timers to production, internalize these 5. Enable the timer, never the service. That's the pair principle biting back. Set persistent true on anything daily or weekly, or missed runs vanish silently. Be explicit about time zone, because OnCalendar defaults to UTC and DST will embarrass you. Add a randomized delay so 1,000 boxes don't hammer upstream at noon sharp. And always absolute paths in exec start. System doesn't read your path even though cron did. Memorize the fix column. Each of these has cost someone a post-mortem. And that closes the operation stage. You can write services, read the journal, and replace cron with timers that actually behave in production. That's fluency. Lesson 08 opens the advanced stage with sandboxing and hardening, protect directives, no new privileges, read-only paths, turning your units into container-grade isolated workloads for free. Security as a service trait. See you there.